The next important concept is thermal equilibrium. Thermal equilibrium refers to the scenario when all species are at the same temperature. So if in the thermal mixture that contains particles of different species and all the particles they are at same temperature, then the system is said to be in thermal equilibrium. If particles are interacting, and we'll talk more about this situation later in the course, we will see that when particles are interacting, then the thermal equilibrium is maintained, which means there is an exchange of energy between different species. And when there is efficient exchange of energy between different species, which means when there is efficient interaction between different species, then the thermal equilibrium is maintained. The temperature of all the species is the same. Now there will also be scenario which we will see later in the course that a certain type of particle stops interacting with the rest of the thermal mixture. For example, we will see this important phenomena called neutrino decoupling. Now, before neutrinos decouple, the entire thermal mixture had the same temperature and hence the total thermal mixture was in thermal equilibrium. After decoupling, we will see and we will derive the expressions, we will prove this, that neutrinos ended up having different temperature from the rest of the thermal mixture. So there will be two temperatures after neutrino decouples. One is the temperature of neutrinos and second is the temperature of the remaining thermal mixture. So the whole universe is not having one temperature but two different temperatures after neutrinos decouple. But before that the entire universe is having one temperature and the entire thermal mixture is said to be in thermal equilibrium. Thanks for watching.